Hey everyone, thanks for joining me on this talk. Glad to be here at Vox Days Brussels. And today I'd like to talk to you about how we gained observability into our CI/CD pipelines and how you can too. I'll use Jenkins as a reference, but the focus is on principles and best practices. So even if you're not Jenkins users, definitely applicable to many other tools of your choice. And I'd like to start with a day in a life of one of our engineers or our developers on duty, the on-call engineers, at least what used to be before the change that I'm going to talk to you about. So as a developer on duty or an on-call engineer, that's how the day used to look like. First thing in the morning, you start the day with your coffee, going over the Jenkins pipelines, and check what happened, what went on in the last few hours. Most importantly, of course, if there are any reds, probably you know this signal very well, and especially if there's a red master on the master branch. And essentially, if you can finish your coffee, or if you need to jump in and see what the heck is going on. So that's what used to be. And if there is obviously one red of these, you need to essentially go into the runs, the different Jenkins runs, one by one, and start understanding what happened, where it failed, why it failed, and so on. And when I mean going one by one, I mean the different pipeline runs. So you have the front end, you have the back end, you have smoke tests, you have many others. So going into each and every one to understand the pattern across the different runs, across different branches, and so on. And maybe another very important point is that there was no easy way to compare that also with historical pipeline runs, historical data. So that's our journey, and the types of questions that we wanted to ask, and maybe it wasn't that easy and straightforward to answer. A few examples you can see here. Did all runs fail on the same step? Did all runs fail for the same reasons? And how many failed on that reason? Did the failure occur in a specific branch, maybe on a specific machine? Which failed the most? If you see suddenly a spike in the latency, taking longer, is that good or not? What's the benchmark even for the normal steady state? So these are the sorts of questions that it took us too much time to answer, and we realized that we need to improve. That was the beginning of our journey with the CI/CD. My name is Dotan Horovits. That's a tweet from my last visit to Brussels back in February. For those who know FOSDEM, Config Management Camp, the open source month, and I also love Belgian beers, so always happy to come back here. And I'm the principal developer advocate at logs.io. Logs.io provides a cloud-native observability platform that's based on popular open source tools such as OpenSearch, Prometheus, Jaeger, OpenTelemetry, and others, and makes it available as a unified platform built for scale. I'm also a CNCF ambassador. CNCF is the Cloud Native Computing Foundation, the open source foundation under which you can find Kubernetes and Prometheus and Argo and probably many other projects that you know and love. So if you have any questions about the CNCF ecosystem or anything related, feel free to catch me up after the talk. Happy to talk about any of the CNCF ecosystem, cloud native ecosystem. And I also have a podcast called Open Observability Talks in English about open source, DevOps, observability. So if you're interested in any of these topics, do check it out on any of your favorite podcast apps or on YouTube. And as you can see, you can find me everywhere at Horovits. So if you want to reach out afterwards and you're shy to ask your question, feel free to reach out. Or if you're tweeting anything interesting out of this talk, feel free to tag me. So going back to our journey, before I go into how we improved our CI/CD, I first want to understand what we need to improve. And I see many users actually jumping into improving without really clearing and defining the KPIs of what they want to improve on. So this is a very basic thing. And for that, I really love the DORA metrics system. Who knows the DORA metrics with a show of hands? Okay, we have only one person, so good thing I've prepared this slide. I'll go over that maybe a bit slower than to show that. DORA metrics, essentially, DORA metrics for DevOps. It started as a research to understand what makes high-performing teams. Then back in 2018, and by the way, you have a QR code here that you can scan with your phone if you want a good overview on like 101 on DORA metrics. But essentially, back in 2018, the team published a very famous book, the Accelerate book, in which they identified essentially 4 different key metrics that indicate the performance of software development teams. And this is the point that I want to share with you. 4 different metrics. First is the deployment frequency, which is essentially how often an organization successfully releases to production. Then there's the lead time for changes, or cycle time, sometimes called, which is the amount of time it takes a commit to get all the way to production. Then there's the change failure rate, the percentage of deployments causing failure in production. And the 4th metric is the time to restore service, or mean time to recovery, MTTR, which is essentially how long it takes an organization to recover from a failure in production. So these are the 4 DORA metrics, very, very useful to track and quantify how effective essentially your software delivery lifecycle is in various terms. The first 2 you can see are more on the developer side. The last 2 are more on the ops side. So it covers really the full spectrum. And as I mentioned, you need to understand what matters to you and what you're trying to optimize on. In our case, we needed to improve on the lead time for changes, the amount of time it takes a commit to get into production, which because of the failure of the pipelines took us longer than it was too high and was holding us back, essentially. So now that we know what we want to improve on, the question is how to get into that. And as I mentioned, at Logs.io, we're experts in observability. That's what we do for a living. So we very quickly understood that we're missing essentially observability into our CI/CD pipelines. And as I mentioned before, we use Jenkins as our tool. And Jenkins did provide us with some observability out of the box. So you could get into the specific pipeline run and then see the different stages of that run and how much time was spent on each one of these stages. So you got some observability. We even hooked it up with Jenkins with our Slack. So we got some alerts on failures. So we did what we could with Jenkins out of the box. But, and that's very important, but it wasn't good enough for us. And I want to share with you, not just, again, even if you don't use Jenkins, just for you to understand the parameters and the aspects that you need to assess in your tool. So in our case, we wanted to find a way to monitor aggregated and filtered information across all the pipeline runs, across all branches, across all machines, in order to see the full picture on a scaled time range with our own filtering demands and our own needs. Just like you do in production, essentially, the way that you monitor production, we wanted to be able to monitor our CI/CD pipelines. So we went into this journey of improving our CI/CD observability with these 4 goals for the project. The first one was achieving dashboards with aggregated views to see across pipelines, runs, branches, as I mentioned before. The second goal was to get historical data, to be able to understand the trends and to identify patterns over time. Thirdly, we wanted reports and alerts so that we can automate as much as possible. And lastly, and very importantly, we also wanted to have observability into our test performance, to be able to see flaky tests, test performance, to understand their impact on our pipeline. So these were the goals. Remember them. We'll get back to them later. And now that we understand what we want to achieve in this project, let's talk about how to achieve that. And essentially, it takes 4 steps to achieve: collect, store, visualize, and report. In terms of the tech stack, we have a lot of expertise with the Elk stack, Elasticsearch, Kibana. Who uses, who knows Elasticsearch, Kibana, the Elk stack? Okay, quite a few. So we started with that on our journey, and I want to show you how these 4 steps are achieved with this specific tech stack. And let's start with the first step, collect. So for that end, we instrumented the pipeline. This is an example of a Jenkins pipeline run. And we instrumented the pipeline to collect all the relevant information and put it in environment variables. Okay, what kind of information am I talking about? So here are a few examples. You can see the branch, the commitcha, the machine IP, the run type, namely schedule triggered by merge to master or by push to branch. Failed steps, step duration, obviously, build number, pipeline status, whether it's passed, whether it's flaky. So essentially all the information, useful information that you can get, put it, store it in environment variables. And then let's move on to the second step, the store step, after collect. And for that end, we created the new summary step that you can see here in red. The summary step at the end of the pipeline, where you ran a command to collect all the pipeline information from the environment variables and essentially create a JSON with the pipeline and then store it on Elasticsearch. We have our own, so for us it was a no-brainer. We have a managed service. And by the way, now move to OpenSearch. I don't know if you know, Elasticsearch is no longer open source, unfortunately, since a few years ago, a couple of years ago. So OpenSearch is the Elasticsearch open source fork of Elasticsearch and Kibana. So we moved, since we're based on open source stack, we moved to OpenSearch, and now we use OpenSearch and OpenSearch dashboards for the visualization. How many use OpenSearch? Just with a show of hands? None. Okay. So one point, we talk about the store phase, and the question that oftentimes comes up in my talks is, what about Jenkins built-in persistence? And there are. And built-in persistence is available in Jenkins, and we tried it, but there are a few downsides. So first of all, by default, Jenkins keeps all the builds and stores them on the Jenkins machine itself. Which burdens these machines. These are the critical path of our pipeline, right? And then you need to start limit how many builds to keep and for how long, how many days, and so on. So, and this was very limited. And we wanted to persist historical data in our control, the duration, the retention, and very importantly, off of the Jenkins server so as not to load the critical path. And we also wanted more powerful access to the historical data to analyze the same way we analyze essentially our production environment. So this is why we went into this journey. So we talked about collect, store, and now let's talk about visualize. So now that all the pipeline run data is in Elasticsearch, it's very easy to build Kibana dashboards and visualizations, or if you store it in OpenSearch, then with OpenSearch dashboards. And the question is, which visualizations shall we build? And here I want to take you back to the beginning of the talk. We talked about the questions that we wanted to answer, because this is the guideline that should lead you. You can use these questions, but the purpose is not to memorize my questions, but rather to formalize your own questions and to let them define the visualizations and the observability that you need. So we talked about before questions such as, did all runs fail on the same step? Did all runs fail for the same reason? Did the failure occur on a specific branch or in a specific machine? If something takes longer, is that normal? What's the benchmark? So these are the questions that helped us define the visualizations. And I want to give a few examples. Again, it's examples, so use them as a reference to guide your process in assessing and defining your observability. But let's look at some examples here. And the first one is the top line, status. Check how stable the pipeline is. Remember that on-call engineer waking up in the morning with a cup of coffee, opening the Jenkins, wanting to understand if everything's okay and they can finish the coffee. This is a very good visualization to start the day. You can see here the success versus failure rates in general, or a specific time range. So you can also choose the type of visualization that fits you. And as you can see, it's very easy to see suddenly a spiking, something red that may call for your attention. So that's the top line. Another example, finding problematic steps. Remember the question? So visualize failures segmented by pipeline steps. Again, very easy to suddenly see a spiking step, whether visually or on the listing. Very nice visualization. Another example, detecting problematic build machines. So for that, we visualized failures segmented by machine. And that, by the way, was very, very useful because it saves wasting time looking for a bug in the released code. When you see something like that, you can just kill that instance, let the autoscaler spin up a new instance, and many times this solves the problem. So it's very, very useful to understand whether it's environmental or code-based issues. And a lot of our runs were actually environmental, so much so that I will get back to environmental later and show you how you can even dive deeper into the environmental issues in your pipelines. Next, duration per step. If you suddenly have latency, what's the normal? What's the benchmark? Is that really an anomaly? So for that, if you remember before collecting the CI/CD pipeline data, we could enter into specific runs and see the specific step, how much it took in that specific run. But what we lacked is to monitor aggregated information across runs, across builds, across machines, and see the trend. So this is the way to now see that as a graph and understand if this is really an anomalous behavior or not. So just to summarize, these are, as I said, just example visualizations. You'll create your own based on your questions and your needs for observability. So after we talked about collect, store, and visualize, the last step is report. And as you remember before, the developer on duty needed to remember to manually enter Jenkins to check the pipelines. Now, life is much easier, much better. You get daily start of day report on Slack, as you can see here on the screenshot. You get notifications, and the notification is actually linked to the dashboard. So with a click of a button, you can jump straight into the dashboard and see what goes on, in the past hours. And there's also an embedded snapshot, as you can see. So you don't even need to get into the dashboard. You see, and if everything is green, you can finish your coffee. But if something catches your eye, then you go in and investigate further. And you can also define alerts on the data, just like anything. You can define triggered alerts with complex conditions on any of the data that we collected on the collect phase. So you can do if sum of failures goes above X or the average duration goes above Y, set an alert. So essentially anything that you can define as a Lucene query. I see that many know Elasticsearch. So anything you can define as a Lucene query, you can create an alert and automate it. And this is done based on an alerting mechanism we built on top of Elasticsearch and OpenSearch, so it's very easy to achieve. And also, it's not just for Slack. We work with Slack in our engineering and DevOps, but you can send it to many other notification endpoints, such as PagerDuty, OpsGenie, MS Teams, and more. So you can even add your own custom endpoint using webhooks. So we personally worked with the Slack, but whichever downstream system you work with. So that was the observability that we were looking for. But that was Jenkins. But CI/CD is more than Jenkins. So what else? What else do we want to achieve? Let's see, who listened in the beginning of the project statements. What haven't we covered yet? Sorry? What do you mean deployments? No, we're talking about the pipeline run. So it's CI/CD observability. The production actually was well covered before that project. So the fourth element in the 4 statements goals was the test performance. I don't know if you remember that. We talked about test performance. So we wanted to analyze flaky tests and test performance. And the process is essentially the same. Following the same process, we collected the relevant information from our test runs and stored them in Elasticsearch, then created Kibana dashboard that you can see here, and all the visualization that you probably would like to have. Let's see, test duration, failed tests, flaky tests, failure count and failure rate, moving averages, failed tests by branch over time, flaky test suites over time. So really, all the things that you would be looking for, visualized with Kibana. And following the same process, of course, after visualize, there's the report phase, and we created for that as well dedicated build alerts, app build alerts, as you can see, Slack channel. And in the Slack channel, whoever was on duty got a Slack message notification with a report summary, link to the dashboard, and so on. So really the same process that I talked about: collect, store, visualize, and report. One very important point to mention is the flexibility and openness. Different teams created different visualizations over the data to suit their needs and their style. So once you have the data in Elasticsearch, it's very flexible, and each team can have. I took the other extreme example, a different team that didn't like any graphs whatsoever. They liked the lists, and they did all of the visualization of the test suites based on lists. I talk about quite a bit about platform engineering in different events and different forums. And this is actually a part where, who has platform engineering in his organization? With a show of hands? No one. Okay, so but if you do have someone that provides sort of a platform infrastructure, this is a great practice. The platform engineering can prepare the data and then make it accessible for the teams. And then the teams have the flexibility, each one, to consume and to visualize and to create their own reports and alerts based on their preferences. Flexibility and openness. So just to summarize how we gained observability, first we instrumented Jenkins pipeline to collect all the relevant data and put it in environment variables. Then at the end of the pipeline, we created a JSON with all the data and stored it in Elasticsearch or OpenSearch. And then we created Kibana visualizations on top of that data. And lastly, we created reports and alerts on the data. Okay? 4 steps: collect, store, visualize, and report. So we have that. What's next? Next, we wanted to investigate the performance of specific pipeline runs. Okay? And what do you need to do in order to do that? We showed some visualization before in Kibana visualization where you saw the visualized per step duration, right? That was a good start, but it wasn't enough to really investigate the sequence, to see really the sequence over time. And that's what distributed tracing is for. How many know and use distributed tracing? Not for CI/CD in general, like production. Okay, so we have a few in the audience. I'll say a word about that. But essentially, that's really something that suits very nicely. And Jenkins, the nice thing is that Jenkins can emit trace data, just like it emits logs. So it was very easy to integrate. So we decided to visualize jobs and pipeline executions as distributed traces. So a word about distributed traces for those in the audience that don't know. Distributed tracing essentially helps to pinpoint where failures occur and what causes poor performance in your system, in your production system. So the primary use is actually not for CI/CD pipelines, but for production environments. And this is best suited for distributed applications for microservice architectures where each request coming into the system goes through a chain of interacting microservices downstream. And then when suddenly you get, I don't know, a 404 at the end point, an error, and you want to understand where the error comes from within this chain of calls, or if you get very high latency suddenly, it takes, I don't know, 200 milliseconds to complete login or some other API call. You want to understand where this latency is coming from in the downstream systems. These are the sorts of questions that distributed tracing helps you answer. And the way it works is that each call in the chain, in our case, each step in the pipeline, creates and emits a span, which you can think about a span like a structured log that contains the name of the operation that was invoked, the method or whatnot, the name of the step, the duration of that step, and additional data, essentially metadata. And then there's a backend that collects all these spans, reconstructs the full trace based on causality, and then visualizes, typically using the Gantt chart visualization that you see on the right-hand side. So it's very easy to see A called B, then B called C, and then D, and then when B finished, then A called E. You really see the sequence. You see how much time each call took, which calls ran in parallel, which ran sequentially, and so on. This is the power of distributed tracing. So let's go back to our process. Following the same sequence that we talked about before, we start with a collect step. And for the collect step, we decided to use OpenTelemetry collector. How many here know OpenTelemetry, heard of the project OpenTelemetry, open source? Okay, so we have a few. So a word about OpenTelemetry. OpenTelemetry is an open source framework for generating and collecting telemetry data from your system. It could be logs, metrics, traces. Actually, very recently added also continuous profiles. So very diverse. So essentially one framework to rule them all of the telemetry types. It's an open source under the CNCF, the Cloud Native Computing Foundation. And you have a QR code here for a guide on OpenTelemetry. I hope that you can see that. So if you want to learn more about OpenTelemetry, check out the beginner's guide. And at the time, OpenTelemetry was already GA for distributed tracing, so we decided to go with that for the instrumentation part. So the process was as follows. We essentially set up an OpenTelemetry collector as a separate component, an agent if you'd like, and then installed on the Jenkins OpenTelemetry plugin. You have the URL here. And then all you need to do is to configure the Jenkins OpenTelemetry plugin to send the OpenTelemetry collector to the endpoint via OTLP over gRPC protocol. That's all it takes for the collect phase. And after collect comes store. For the backend, we used Jaeger. Who knows Jaeger project? Okay, so we have a few. Jaeger is a very popular open source tool for distributed tracing. It's also a project under the CNCF, the Cloud Native Computing Foundation. So, and we use Jaeger to monitor our production environment. So we and we have it as our own managed Jaeger service. So for us, it was a no-brainer to use that also for the CI/CD pipeline. But I'm showing the case here for Jenkins, even if you self-host it. You have even a link here if you want to a guide on how to deploy Jaeger and Kubernetes in production. So check out that URL. Works just the same. So as we use Jaeger for the backend, we need to configure the OpenTelemetry collector, essentially. So OpenTelemetry collector, the trace data is aggregated and then sent to the Jaeger backend for storage and indexing. And then after store comes visualize. Here it's much easier than with Kibana. You don't need to start building your own visualizations. There are built-in visualizations. Simple case, Jaeger UI has this Gantt chart that I talked about before. And as you can see, it's very easy to see the step sequence of the run. On the right, you see, on the right-hand side, you see each, let's start with the left, actually. You can see this tree structure that shows you the nested calls. So you really see which one calls which. And then on the right-hand side, you can see the length, the duration of each step, and the sequence, how much time each step took, and which one is the one that is running in parallel, which one runs sequentially. So for example, these two ran in parallel, but these ones, only when this finished, these ones started. So it's very easy to see where the latency is coming from, where the time is spent, and so on. And Jaeger offers, besides the timeline view, also other views, like a dependency graph view, trace statistics, flame graph was recently added on the button here on the top. where you see trace timeline. So this is the most used ones. This is an example of the graph view. And as I mentioned, when you click on the button on the right, top right, you see the other options for visualizations. Really powerful visualizations built in. This is the graph, flame graph that was just recently added. Really cool visualizations. So that was adding traces to our Jenkins runs. But as before, CI/CD is more than Jenkins. So what's next? What you can later do is to add instrumentation to Maven in this example, or it could be Ansible, Artifactory, and other tools to get finer granularity of the traces and the steps. In this example, as I said, the yellow, what you see in yellow is Maven. So what before appeared like one long black box span, now you can open it up and see the different build steps that the breakdown into the different build steps within Maven. So it gives you finer granularity to understand where things take time. And similarly, as I mentioned, you can find other common frameworks having integration with OpenTelemetry, like Ansible plugin. For testing, you have Java JUnit, Jupyter plugin, Python, and so on. So really very powerful. This is where you can take it next step after the Jenkins itself. So we've seen what it takes to add tracing to our CI/CD pipeline, following the same steps: collect, store, visualize, and of course you can create alerts on the traces as well, just like we've done before with the log data. So what's next? As I mentioned before, when we talked about the causes for pipelines failing, many of the pipelines fail not because of the released code, but because of the CI/CD environment itself, environmental issues. So before I showed on the Kibana dashboard that we see suddenly a spiking machine that with higher rate, that's fine, but we wanted finer granularity. We wanted to monitor metrics from the Jenkins servers and the environment, the system, the containers, even the JVM, anything that essentially can fail irrespective of the released code. So that was the same, the next step in our journey, and following the same steps: collect, store, visualize, and report. So let's see how it's done. For the collect phase, we used Telegraph. Actually, today we're going to OpenTelemetry that already supports metrics, but back in the day, metrics was not GA in OpenTelemetry, so we went with Telegraph, and we use that in production. So we use that as well in our system. Telegraph. Who knows Telegraph? With show of hands? No one. So Telegraph is part of the open source suite by Influx Data. So it comes together with InfluxDB and others. There's the tick stack, for those who know their stack. But just so you know, you can do the same with OpenTelemetry or other shippers. Just an example. Essentially, collect phase has two steps, as you can see here. First, we need to configure Jenkins to expose metrics in a Prometheus format. We use Prometheus formats extensively in our production, so that was our natural choice for monitoring. And that's a simple configuration in the Jenkins web UI. And then the next step is to install a Telegraph instance, if you don't already have one, running, and configure Telegraph to scrape the metrics off of the Jenkins servers with a Prometheus input plugin that you can see here. Prometheus input plugin. And that's all it takes for the collect phase. And then, after collect, we have the store. I mentioned that we use Prometheus extensively. Who uses Prometheus, just out of curiosity, for metrics? OK, so we have a few. So Prometheus, again, another open source database, time series database to collect metrics, time series data. We use it in production. So we follow the same for the CI/CD pipeline. We have also our own managed Prometheus, so it's a no-brainer, just plug it in, but it works with a self-managed Prometheus the same way. You just essentially configure Telegraph to send the metrics to Prometheus, and you have two options for that. You can do it in a pull mode, or in a push mode. So if you do it in a pull mode, you use the standard, pull mode is the standard Prometheus way. So if you have your own Prometheus instance, it will by default scrape in a pull mode. That's called scraping in Prometheus terms. And then all you need to do is to configure Telegraph to expose a sort of a slash metrics endpoint, and the Telegraph will scrape that endpoint. So, and for that, you just configure the Prometheus client output plugin. If you want it in a push mode, so that the Telegraph pushes to your backend of choice, then use the HTTP output plugin, and remember to set the data format to Prometheus remote write, just as the format to be used. So that's the store phase, and after store, once we have everything in Prometheus, obviously very easy to build Grafana dashboards on top of it. And here, you'll build your own visualizations, just like we did with Kibana, based on what you want to do. But just to give you ideas, first of all, let's talk about the filters. You see the filters here at the top. So being able to filter by build type, by branch, by machine ID, by build number. Remember all these things that we talked about before that you want to be able to very clearly understand if it's a branch issue, if it's a machine issue. So the filters give you all these capabilities. And of course, you can monitor the system metrics, what you can see here on the screenshot, like CPU, memory, disk, usage, load, trend over time, all the things on the system level. Then you can have also monitoring the Docker container metrics. As you can see here, some examples, the container CPU, memory, I/O, network, disk usage behavior, and also, of course, the running, stopped, paused containers by Jenkins machine. And as we said, we can filter all of that to investigate a specific machine, a specific build type, a specific branch, or any combination of the filters above. So that's on the container visualization. We also show the JVM metrics of the Jenkins machine, such as as you can see here, where you can see thread count, heap memory usage, garbage collection duration, all the things that you would expect on the JVM level that can screw up mess up our pipeline run. And of course, you can monitor the Jenkins nodes and queues and executors themselves. These are the native Jenkins entities. So you can see here monitoring the queue size and status breakdown, buildable, blocked, pending, stuck, all these statuses. This is the queues, and then the jobs, the count of executed over time, the breakdown by job status, how many aborted, how many failure, how many not built, success, unstable, and so on. The job duration. These are so useful that actually we made some of these available as pre-built dashboards that even our users can install with the click of a button, because it was really, really useful to not just to us, apparently to others as well. So pretty cool. And we can also set alerts on these metrics, just like we said. So after visualize, we can do reports. So I want to summarize what we've seen here in this journey. I know it's a lot of information, but the principles are what matters. First, treat your CI/CD just like you treat your production environment. Just like you use Elasticsearch or OpenSearch, Prometheus, Grafana, Jaeger to get observability into your production environment, do the same with your CI/CD pipelines. And also leverage the same stack. So if you have a stack that works for you and your team for production, don't reinvent the wheel, just use the same, try and reuse as much as possible for your CI/CD pipelines. As I said, we embarked on this project with these goals in mind. First, we wanted dashboards to see aggregated and filtered information from several pipelines belonging to different runs, different branches in our time range of choice. We wanted historical data and controlled persistence off of the Jenkins servers, as we mentioned, and to determine the duration, the retention of the data in our control. We wanted reports and alerts to automate as much as possible. And lastly, we wanted to see flaky tests and test performance in general and their impact on the pipeline run. So that's the journey, and this is how we achieved that in a summary. And again, 4 steps. If there's one thing to that you take out of this talk, take this principle. 4 steps to achieve observability: collect, store, visualize, and report. Collect is instrumenting your pipeline to get the events, the metrics, the traces, then store and visualize according to the data type. Elasticsearch, OpenSearch for logs and events, Prometheus and Grafana for metrics, Jaeger for traces. This is the stack that I showed here. Of course, you can use your own stack. And then get alerts and reports to automate. So this is the principle. It could be self-managed. It could be Logs.io as a unified platform. That's my employer. So a hook to my employer if you want to check out the free trial for that. And very important, what we gained out of this journey. Okay, let's zoom out. The first thing, we got significant improvement in our lead time for changes. If you remember the DORA metrics we saw at the beginning, significant improvement there. Also improved on-call experience. The developer on duties experience is much more friendly these days. And also it's based on the open source stack that we know and love. So nothing new to learn in order to achieve that. This is our journey. If you want to learn more about CI/CD observability, I wrote a guide to CI/CD observability. You can scan this QR code. It gives a lot more information about each and every one of these steps that I talked about here, and the different open source tools that you can use for each one, and so on. And one final note that I want to say is about standardization on CI/CD observability. So we've sort of reinvented the wheel. As I said, we collected different types of data. We saved it in environment variables or some other mean. But the question is there sort of a standard way to do that? And until very recently, there hasn't been. And I'm glad to say that we've started a working group under the CNCF, the Cloud Native Computing Foundation, to actually standardize on CI/CD observability as part of the OpenTelemetry open source project or specification. So there's now an active special interest group on formalizing the semantic conventions needed to make that. The vision is essentially that once we have unified semantic conventions on these CI/CD events, then each tool can then emit its CI/CD data in a uniform manner, and then you don't need to reinvent the wheel. You can use whichever tool you choose, but you can, it will be uniform across the different instrumentation tools of choice. So whether it's Jenkins or Circle CI or GitHub Actions or whatnot, you'll have each one of them will emit in the same way, and then you choose the way that you collect and visualize and aggregate and so on downstream. That's a very cool working group that I'm glad I was one of the initiators. And if you are interested in this domain and if it's something that you're passionate about, it's open source, it's community driven. So do reach out to me afterwards. Happy to give you more information and see, and you can actually take part and help us shape what these semantic conventions look like, what this standardization should look like for greater good as a community. So this is about that. And again, you have the guide if you want some more information on that. With that, I'll wrap up. It's still the month of May, so I'll also greet you what I said a couple of weeks ago when I was at DevOps UK. May the open source be with you. And thank you very much for listening.